Hey, I'm Amanda Olson, and this is Calculus 1, Math 2410 at MCC. We are looking at a problem from section 3.3. If you are in my hybrid class, this comes from number 7 on the practice problems. This problem deals with increasing and decreasing. I decided to switch it up a little bit and do one that involves a trig function. And so because of that, I've taken a copy of the unit circle that you are allowed to have on the test. All right, so in this problem, it says find the open intervals on which the function is increasing or decreasing, and then express your answer using interval notation. So in order to consider increasing or decreasing, we have to know the derivative and look at the critical numbers. The critical numbers being the place where the derivative is equal to 0. We know we're either going to transition from increasing to decreasing or vice versa. So we'd have that hill or those valleys. And so it's where we're going to have those increasing and decreasing changes. So we start off with those. We look at what is f prime of x. And so the derivative of sine x with respect to x is cosine x. The derivative of cosine x with respect to x is minus sine x. From there, we want to know where is that equal to 0. And we're doing that to find the critical values. Well, f prime of x is going to equal 0 if and only if cosine of x minus sine of x equals 0. And that's going to happen if and only if adding sine x to both sides, we get that cosine of x is equal to positive sine x. Okay. So now we're looking at where does cosine of x equal sine of x? For referring to the unit circle, it might help to think of that as theta, but we're really looking at for what values, what input into the cosine and sine function do we have the same output? So in other words, where is sine and cosine the same? So on my unit circle, that's going to be right at the line y equals x. Remember, when using the unit circle, sine of my inputs are going to correspond with my y values, and cosine of my inputs is going to correspond to the x values. So for what points on my unit circle do I have the same x and y values? Looking at that, I see that I have a 45-degree angle, or pi over 4. So this is going to occur if and only if, now again, you can use x or you can use theta, but it's going to occur when our input is pi over 4. And then we also see the same for negative square root 2 over 2 being outputs where sine and cosine are the same. And that occurs when x, or your input, is equal to 5 pi over 4. As a result, pi over 4 and 5 pi over 4 are our critical numbers because that's where sine and cosine for their given input have the same output. All right, so then we want to make a table of values. We should mention that our function was given to us over a restricted domain, which can help us set up our table. So we have, starting from the left, we go from x equals 0 all the way up to our first critical number, which is pi over 4. That gives us our first interval. Our next interval we have from pi over 4 to 5 pi over 4. Our third interval is going to go from our critical value of 5 pi over 4 to 2 pi. Now we are just concerned with what our sine of f prime is, so you don't necessarily have to go through and compute everything that is f prime. I do recommend, though, picking a test value in that interval. Find f prime of your test value. Or what you could do is you can consider what's the sine of f prime. Because again, we're not really concerned with what explicitly is f prime. We're just concerned with if it's positive or negative, and sometimes that can save us a little bit of time. And then what's the conclusion we can draw based on the sign of f prime for that given interval? So when I'm looking for 0 between 0 and pi over 4, I'm going to use pi over 6 because that's a value that's in my table. Okay, and I see that f prime is equal to cosine minus sine. So I'm going to go ahead and say, okay, what is f prime of pi over 6? For pi over 6, I have, keep writing pi over 2. Pi over 6, I have cosine of pi over 6. Cosine of pi over 6 is going to be square root 3 over 2 minus sine of pi over 6, which is going to be 1/2. Square root of 3 is larger than 1. So this is going to be positive. So the sign is positive. If you want to write positive, that's also fine. We aren't really concerned with the explicit value of it. Our conclusion, based on the fact that it's positive, is that we have an increasing function. Between pi over 4 and 5 pi over 4, we have a lot of different values that we can choose. Since f prime is equal to cosine of x minus sine of x, I'm going to choose where I have cosine starting. So I'm going to choose pi. There we have -1 minus 0. This is going to give us a sign of negative. And so we can conclude that our graph is decreasing from pi over 4 to 5 pi over 4. From 5 pi over 4 to 2 pi, I'm going to choose the point 3 pi over 2. For 3 pi over 2, cosine of 3 pi over 2 is equal to 0 minus a -1. This is going to give me a positive for 3 pi over 2. So this is going to be increasing. Now I started off writing f prime of pi over 6 explicitly, and then I kind of just talked through it. You might have to write out explicitly and calculate 5 pi over each one of these test values, and that's okay. Your goal is at the end to see, is it positive or negative? Now, sometimes I show less steps, you might have to show more steps, that's okay. Sometimes when you show more steps, you might even catch me making an error. I'd like to tell you that's intentional, but it's not always. So don't be afraid to pause the video and write out more or less steps. You kind of know what you need to have. So our conclusion then, though, is that we are increasing on the interval from 0 to pi over 4, and then union 5 pi over 4 to 2 pi. We are decreasing on the interval from pi over 4 to 5 pi over 4. Okay, thank you.